All right, so now we're going to look at covalent compounds and acids. Covalent compounds are wicked easy though. So when you have a covalent compound, and you're only going to be taught how to name binary covalent compounds for now. So basically, if you have two non-metals, these are molecular compounds, so you have to make sure you go with a different system for naming and formulas. So you use prefixes for naming covalent compounds. And a prefix is not needed for the first element if there's only one. So if you only have like one of the first thing, so like let's say that I have CO. I only have one carbon atom here. So instead of saying monocarbon, I would just say carbon and then complete the name. And then change the ending of the second element to IDE, just like in binary ionic compounds. All right, so with formulas, you just use prefixes. That tells you how many atoms you have of each element, and that's it. All right, so just know these prefixes. So mono is 1, di would be 2, tri is 3, tetra 4, penta 5, and so on. Most of these are pretty self-explanatory. Some of these you'll have to make sure you just memorize it. All right, so first thing, when you are naming, remember, first thing, is it ionic or is it covalent? So boron and chlorine. If you have your periodic table out, which you should, you'll see that they are both nonmetals. So we have a covalent compound, so we need to look at prefixes. So we have one boron, but because boron is the first element here, we're just going to say boron. If we had more than one boron, we would have to add a prefix here. But since there's just one and it's the first, we don't have to have monoboron. All right, so boron, with chlorine, we have 3 of those, so the prefix is tri. So chlor, and then you have to change the ending to IDE, so boron trichloride. All right, so looking at the next one, I've got 1 carbon, so again, I can just write carbon. No mono necessary because it's the first one. And then I've got 4 chlorides, so tetra would be my prefix here. And that's going to be chloride. All right, so next one. Again, I've only got 1 of the first one, so it's just carbon. I don't need a prefix. And then here I've got 1 oxygen, but because it's not the first element here, I've got to add the prefix mono. So mono oxide. All right, so next one. Again, I've only got 1, so it's just carbon. I've got 2 oxygens, so 2 would be di, and then oxygen would become oxide. Next one. I've got 2 nitrogens, so I do need a prefix, so it's going to be di, nitrogen. You don't need to change the ending here, just the second part. So dinitrogen. I've got 5 oxygens, so that one would be pent oxide. Next one, I've got 1 nitrogen, so just nitrogen. Okay, so just 1 nitrogen. And then I've got 2 oxygens here, so the prefix is di. And that would be dioxide. All right, so it's really simple to name covalent compounds. It's even simpler to actually write the formula. You just have to know, is this ionic or is this covalent? All right, so give the formula. Okay, so the first thing, if you have a formula with prefixes, there are no charges here. So if you have prefixes, automatically you should know, okay, I don't need to worry about charges at all, I just look at the prefixes. If you have 2 nonmetals, then you know it's covalent, but right off the bat, you see these prefixes and you know it is covalent, all you need to do is just write how many atoms for each prefix. Okay, so di-nitrogen. I've got nitrogen. Di is 2, so there's 2 of those. Tetraoxide, oxygen, has 4. Tetra means 4. So it's N2O4. Do not reduce here. No reducing with this. Even though 2 and 4 can reduce, you will not reduce covalent compounds. All right, so phosphorus, penta. So there's that prefix. I know I just go with the prefixes. Phosphorus, there's only 1, so it's just P. And then chloride would be Cl. Well, there's penta, which would be 5. So PCl5. Iodine would just be 1. And then fluoride, I would have 3. So IF3. That's it. And then dihydrogen, well, hydrogen has 2. And then mono-oxide, so 1 oxygen, which is just another way to say water. Okay, so let's look at what happens when we have mixed.
Fernando Castanova, please return to the front office. Fernando Castanova, please return to the front office.
Okay, so let's look at what happens when you don't know if it's ionic or covalent, because it's not like I just went over that. So let's look at each of these, decide if it's ionic or covalent, and then either give the name or the formula. All right, so potassium sulfide. Automatically here, I have a metal. Okay, so I have a metal and a nonmetal, so that means it is ionic. I need to look at the charges. So potassium has a +1 charge. Sulfur has a -2 charge. All right, so I look at the charges and I switch. So it's K2S. All right, let's look at the next one. Cl2O. Okay, so chlorine and oxygen. Chlorine and oxygen are both nonmetals. And if you look at the periodic table, they're very close together on the right-hand side of the periodic table, which means it's a covalent compound, use prefixes. Okay, so I've got 2 chlorines, so that would be di. Chlorine. So 2 chlorines, and then I've only got 1 oxygen, so mono. So you only use prefixes if it's covalent. All right, so copper 1 phosphate. I need to give the formula. Well, copper is a metal, so it's ionic. I need to look at the charges. Copper is a +1 charge. It says so right there. Phosphate, well, phosphate, that is a polyatomic. If it ends in 8 or 8, it is a polyatomic for sure. So PO4 with a -3 charge. Hopefully you looked that up, or maybe you just know it. All right, so now we switch. So pull the metal down, pull PO4 down, make sure you pull the whole thing down. The 1 comes down here, don't need to write that though. And then the 3 comes down here. So it's Cu3PO4. And that's it. 3 and 1 are the numbers you pull down, so you don't need to reduce. All right, so let's look at the next one. BaO. Well, Ba is a metal, so it's ionic. No prefixes then. So Ba is just barium. And oxygen is, oh, and we also don't need to include the number because it's not a transition metal. It's not a metal that has more than 1 charge. And then oxygen becomes oxide. All right, so let's look at the next one. Sulfur hexafluoride. Oh, I got a prefix. If I have a prefix, I just go with the prefixes. So sulfur, no prefix, so that just means 1. And hexa is 6. So fluorine would be 6. All right, so next one, ammonium nitride. Ammonium is a polyatomic. If I have a polyatomic, it is an ionic compound. So I need to look at the charges and switch. So ammonium is a polyatomic. It's got +1 charge. Nitride would be nitrogen. If it was a polyatomic, it would be nitrate or nitrite with a T. And if I look it up on the periodic table, it has a charge of -3. All right, so pull the polyatomic down, pull the positive one down first, then pull the N down, then switch. 1 comes down there, don't need to write that. 3 comes down there, but you have to put it in parentheses. So it's parentheses NH4, 3, N. All right, let's look at the next one. FeNO3, 2. Okay, this is a metal, so it's ionic, no prefixes. So the first part is Fe, or iron. All right, and then iron, if I look it up, has more than one charge, so I need to figure out what the charge is. So this is the first part, so this is the second part, so that would be nitrate. All right, so nitrate has a -1 charge. There are 2 of those, so that's a -2. So if the whole thing is 0 and there's 1 iron atom, each one of those has to be +2 to make it equal 0. So it's iron 2 nitrate. We're going to do a lot of practice with this, but I want to go ahead and look at acids as well. Okay, so acids are covalent compounds too. It's hydrogen, or most acids. Well, acids are. All right, so I want to look at acids now. Acids begin with H, so like HCl, HF, H2SO4, and these are covalent compounds, but to some extent we can actually treat them like ionic compounds because of the hydrogen. The hydrogen is so small it can become an ion very easily. In fact, acids will form H+ ions when they go into water. Okay, so they also have special naming systems. Okay, so for naming, we're going to change the ending of the anion, and remember that's the negative one. So the anion is negatively charged. And you're going to follow these rules. If it ends in IDE, you're going to change it to IC, acid. You're going to add the hydro as a prefix if you do that. So like if I have HCl, well, if I name this, it could be hydrogen chloride, but I would have to change that to name it to an acid because it starts with H. So it would be hydrochloric acid. So if it has only 2 elements, you have to have the hydro prefix and the ic ending. Oops. All right, so if it ends in 8, you're going to just change the ending to ic acid. So if it was hydrogen sulfate, or actually if I just have H2SO4 like this, well, this ends in 8. So it would become sulfuric acid. If it ended in ite, I'm going to change it to OUS acid. So if it was this instead, SO3, this is sulfite, it would become sulfurous acid. Okay, so when you have a formula, when you're just trying to make the formula from the name, you're going to treat it like an ionic compound. You're starting with the H+, that's your metal. Hydrogen comes first, and then that's pretty much it. You just treat it like an ionic compound. All right, so if I'm looking at this, it's HBr. It begins with H, so I know it's an acid. All right. This is bromide. Oops. Okay, this is bromide. If it's two elements, basically, what you're going to do is you're going to say, okay, it should be a hydro prefix. It's got two elements, so it's got a hydro prefix, and then it would be bromic acid. So hydrobromic acid. So if I had like HCl, well, it's two elements, so I know it's got to have the hydro prefix. And then that ending becomes chloric acid. Okay, H2CO3. Okay, so let's look at the last part. We know it's an acid because it ends with C, or because it begins with H. Okay, so if it begins with H, it's an acid. The next part is CO3. Okay, this is not two elements, so no hydro prefix is necessary. The carbonate becomes carbonic acid. So this is just carbonic acid. It's a little infuriating. Sorry about that. Okay, so this becomes carbonic acid. Okay, so let's do another one like this. Okay, so let's do we'll do another one. We'll do H3PO4. Okay, so this one, it's more than two elements, so no hydro prefix. So just look at the last part. It's PO4, which is phosphate. So it becomes phosphoric acid. I could do, let's do one more. Let's do, oh, okay, I know. This one. Okay, so again, this is more than two elements, so no hydro prefix here. I just look at the second part. That's ClO3, which is chlorate, so it would just become chloric acid. All right, so let's look at the next one, H2SO4, or SO3. Okay, so again, this begins with H, so it's an acid. So we know this is more than two elements, so that means that no hydro prefix. Look at the second part. SO3 is sulfite. It ends in ite, so it becomes sulfurous acid. Let's look at, I know, this one, PO3. Okay. Again, begins in H, so it's an acid. It's more than two elements, so no hydro prefix. I'm going to look at this part. So look at the second part. It's phosphite. It ends in ITE. So this would become, instead of phosphite, it would be phosphorus. Sorry, that's really messy. All right. And maybe we'll do some more practice with this. But let's look at how to put the formulas together. Okay, so hydrofluoric acid. All right, so if I look at this, it has a hydro prefix, which means it is two elements. So it's got hydrogen in it. It has to if it's an acid. And it's fluoric. So the other element has to be fluorine. So you need to look at the charges when you put the acids together. So again, there's a hydro prefix, so there's two elements. There's no polyatomic. It has to have hydrogen in it, so it's going to be H+. And then the fluoric, well, that just has to be fluorine. So, +1, -1. They cancel, so just one of each. So it's just like an ionic compound, except you're using H+ instead of a metal. All right, so sulfuric acid. So sulfuric acid, no hydro prefix means there's a polyatomic. Oops. It ends in ic, so it has to be the polyatomic that ends in 8. Okay, so sulfuric, so it has to be sulfate, which is SO4 with -2 charge. And it's an acid, so it has to have H+, and it always starts with H. All right, so bring the H down, bring the SO4 down. The 2 will come down here, 1 will come down there, but you don't need to write that. So it's just H2SO4. All right, nitrous acid. Okay, so no hydro prefix means there is a polyatomic there. If it ends in OUS, it has to end with ITE. So it has to be nitrite. So it has to be NO2 with a -1 charge. And of course, it has to have a hydrogen in it. So it's H+. So it's going to be H +1, -1, they cancels, just one of each, H and O2. Okay, so if you have the hydro prefix, that means that it's just 2 elements. If you don't have a hydro prefix, it has a polyatomic in it. If it ends in ic, that would be the 8, and then if it ends in OUS, it is the 8. And then always just treat it like a polyatomic or an ionic compound and switch the charges. All right, so let's look at the last thing, which are hydrates. Okay, so a hydrate is an ionic compound that is surrounded by water molecules, which hydrate. It's hydrated. If the water is removed, it's said to be anhydrous, so without the water. If you name a hydrate, just name the ionic compound, and then use a prefix to indicate the number of water molecules. So, for example, if you have this is how you're going to know it's a hydrate if you just have the symbols. Okay, so you have an ionic compound followed by a multiplication sign and water with a number in front of it. So if you have that, that is a hydrate. That means it's just whatever this is plus 5 water molecules in this case. So this one would end up being copper 2 sulfate. And then the next part would just be penta, because I'm going to use a prefix to indicate how many water molecules. Hydrate. I'm just running out of space here. So this would be copper sulfate pentahydrate. So you're just adding a prefix to indicate how many water molecules plus hydrate. And you're going to see this. You just need to know what the symbols mean. It's not that hard to name as soon as you recognize what it is, though. All right, and we will be doing lots of practice in class, so don't worry if you're still a little lost.